Hey, my name is Gautam Sanka, and my honors thesis is on implementing mobile health records in low-resource settings. And I got started on this project when in summer 2012, when I went to the Care Rural Health Mission in India. They supported 200 villages in 3 states through a combination of on-site doctor visits and telecare. And what they were facing a problem with was that they had a lot of healthcare workers at these clinics taking these records and putting them up in books, and they just had carbon copies being sent to their central facility in Hyderabad every 2-3 months. But what they really wanted was to really digitize this format and make this electronic. And I was like, isn't this already being done a lot of places? But a lot of village health clinics throughout the world have not digitized, and I wanted to really think about what the best way, low-cost framework to do this was. So to give you an overview, what are electronic records? They're basically detailed of a patient-doctor visit from the moment the patient comes in with their demographic information, any diagnoses, blood pressure results, medical services, and treatments. And this is a combination that has been created from the 1980s onwards and are basically used throughout all healthcare facilities in developed nations now. But we want to make a really bare-bones structure like this for low-resource settings. And so to define what a low-resource setting is, from a healthcare perspective, we can look at 3 major factors of physical capital, consumables, and human resources. In terms of physical capital and consumables, they're really small clinics, they have limited bed facilities, and there's a lot of infrastructural challenges. And they all have preliminary operations, but they don't, if a patient comes in and actually needs serious attention, they get referred to a larger healthcare facility. And human resources is where the major disadvantage for small clinics occurs. They usually have 1 health worker, and they have very limited availability for physicians. And so the whole crux of the operation of these clinics relies solely on this health worker. And so when you want to select a tool to make this whole system happen, you want to make sure it's working well for the health worker. And because smartphones and tablets have become so cheap, the ideal choice for data entry for the health worker seemed to be a smartphone application, and the choice of Android was solely a monetary issue. So in terms of usability, basically you want to make sure that the health worker is not facing too much of an issue from transitioning from a paper-based data entry source to the mobile front. So you want to look at the health worker capabilities from their proficiency in the language of the application that's built in, the level of education that they have, and their comfort with using smartphones and touch-based interfaces. And some of the usability heuristics that I took really into account are these 5. These were developed by the Nielsen-Norman Group in 1995. And of course, there were no smartphones and things back then, but some of the same design principles can be passed over. And 2 of the major things that I really liked was user control and freedom and visibility of system status. You really want the health worker to know to be in full control of the data that's being put in. If there's so many mistakes, you want them to be able to go back and edit and whatever. And also to make sure that they know what the system is doing and what state it is in at all times. So if it is uploading some particular amount of data, you want them to know at what, how much it's been uploaded or not. And so, and then you want to look at the data management model. This is where the crux of the operation, you have all the records being stored. And so with the availability of 2G, 3G data coverage in many places in rural areas of India, as well as other developing nations now, you have the capability now of clearly just putting in data into your smartphone and having that uploaded to a database online that could be viewed by anyone with access to it. And so now you want to look at the type of storage you have on the cloud database. And so what I found was health clinics throughout the world are basically have a dichotomy of 2 things, where you have one is primary care and the other is chronic care. Primary care are normal checkups that people come in for one-time visits. They have a problem, they get it solved, and it's done. And whereas you have chronic care, people have chronic illnesses, and there's actually a progression of indicators that you want to track over time. And as such, you want to have a focus on the patient itself. So for primary, if the healthcare clinic is purely a primary care clinic, we thought, okay, spreadsheets would be very simple for this. It'd be easy to use, and so low learning curve. Whereas for chronic care, you need a relational database. It's not possible to use spreadsheets for it. It just becomes really ugly. And so with the transmission of data, I thought this would be a very easy thing to do. Why store the data on your local smartphone when you can just transmit it really quickly? But it quickly became apparent that was not the case. There were many places where, at one location of the village, the 3G data connection would be perfect. Other locations would be really crappy. So you really want to also have a local storage of data on the smartphone hard drive. And then when you're dealing with local storage, you also deal with security. You have highly sensitive data regarding all these villagers on this health worker's smartphone. And so you want to also take precautions regarding this. And so you want to encrypt the local hard drive with a passcode that can only be written to it with the health worker. And also a lot of education with the healthcare worker to make sure that they're only using the smartphone in the domain of the facility. And so once the secure connection is established, you can upload the information, and you also want to make sure there's no duplicates to decrease transmission time, and also you just don't want to keep on uploading the same database all the time. And so with this framework in mind, I went ahead and created this proposed system for Care Rural Health Mission there. And they had primarily primary care clinics. They only had 15 chronic care clinics. So I focused most of my time on creating a primary care application. I used Google Spreadsheets because their API was very easy to build into their Android mobile system. And it was familiar to use. All the doctors were able to use the spreadsheets fine. So the next major bulk of issue came in to select the fields for records. And this took about 2 weeks to actually do. But this was finally what I ended up inputting into the mobile application. And as you can tell from the selection of the patient demographic information to what the symptoms were, what the vitals were, and all these test results that varied by clinic in terms of what resources they had to implement. And the patient diagnosis and patient prescription were the major, slides for the application. And for each of this, I had to make sure, I had to do a lot of usability testing with the health workers to make sure that they were able to use it. And some of the major concerns that came up were their limited English proficiency. And at that time, 2 years ago, I was using Android Gingerbread, and they didn't have support for Indian languages for their scripts yet. So we had to use English, but now developing with the newer Androids, you can, and go ahead with that. And so a lot of problems we faced were with typing. It was a really small smartphone. They hated typing on it. And so I went ahead and made sure, tried to make everything as selection-based as possible. So the only typing that they had to do was really during the patient identification. And the rest of them were either radio buttons or autocomplete text. For patient symptoms and things, there's a list put out by the WHO called ICPC2, and they have practically every symptom you can think of, practically every diagnosis. And so I input this into a database that the Android system looked at. So if a healthcare worker typed in the first 3 letters of it, all the remaining options would show up, and they could select the one that they wanted. So it was a very easy to use, and this took a lot of testing with the healthcare worker to make sure it happened. And the actual development happened through Java because Android is primarily a Java application, and the only 2 APIs I used were spreadsheets and JXL to store the data on the local storage. With the data connection, what we recommended was having a daily synchronization for the health worker. So after a day's worth of records being placed into the local storage, then you have a daily synchronization at the end of the day. These are some of the screens for the application that I created. It's very simple, very minimalist. There wasn't too much clutter. I tried to put some more design elements into it, but I think that actually hurt the application for the healthcare worker. They didn't understand it. They really liked just the bare bones aspect of it. And in conclusion, by the end of my summer there, I had successful transmission of records from 3 villages there to the cloud database. The analysis that should be done afterwards is whether there's actually an improvement in patient care, because that's the goal of the whole application. Are the doctors in these remote cities able to make better decisions based on the history of the patients in front of them? And so these are questions that are yet to be answered. In future, one of the major things that I wanted to get placed in the application was drug supply management. Right now, literally health workers would call up whenever they were low on drugs, and then they'd get them supplied. So if we had a system where when doctors prescribe drugs, it would automatically be taken out of the inventory, and then you get alerted. And so there'd be more accountability, and it'd just be a better system for the drugs. I'd like to thank my advisor, Dr. Hye-Chung Kum, Care Rural Health Mission, and the Birch Fellowship for providing me the monetary resources to go and do this. Thank you. Any questions? Yeah, there was another literally layer of things that told it whether this particular record had been changed or not, and so then it would go through and change every aspect of the cell. Yeah. Mm-hmm. So Google has its thing called OAuth 2.0. It's like a Google client ID secret, so only things that you pre-authorize the application that you're using to access it. So there's a lot. You store an API token on there, and so there's a lot of things to go through. So it's pretty hard, I feel like, to get. I mean, I'm sure it's not, but for this usage, I felt like it was fairly secure. Yeah. So the initial thing, I thought it got slowed down a lot because they had to take in all the demographic information at the beginning and they had to type all that up. So initially you would just write it up, which was much faster. But I think for accountability and for later purposes, this data storage was much better because it was available to everyone and it was just much more transparent. From me, actually. Yeah. Yeah. Yeah.
Is the size of the issue or of the data that you're locally storing compared to the capacity storage of the Android phone a non-issue?
Because it's all text. It's all text, right? I mean, we're assuming that the smartphone is only being used for that application, in which case it would. I mean, there's 10 gigs on the smartphone, so yeah. Thank you.